Okay, so continuous time Markov chain limiting probabilities video number 2. So how do we get the limiting probabilities using the Q matrix? So number 1, you're going to transpose Q. Easy enough. Number 2, we're going to replace the last row with ones. And number 3, we're going to use B is still a vector of zeros. And the last element is a 1. So this is similar to what we did with the AF equals B model for discrete time Markov chains. And then, once we have A and B, we're going to solve X equals A inverse B. We can use MATLAB to do that. So in our example, we had our transition matrix. So I'm going to start with Q. And here's our transition matrix. And I'm going to transpose that bad boy. And I'm going to have minus lambda, lambda 0, mu minus mu plus lambda 0, 0, 2 mu minus 2 mu. Okay. And to get A, it's just the same thing, but I'm going to copy the first 2 rows. And I'm going to put in ones. So there's my A matrix. My B vector is just going to be 0, 0, 1. I think this is actually B transpose. And then I'm going to take the inverse of A, multiply it times B, and that'll give me my limiting probability vector. So obviously with symbology I can't really plug that into MATLAB. But try this yourself. Let's let lambda equals 1/2, mu equal 1. So pause here, set that into the matrix. Actually, I'll just go ahead and do it. A equals, and if we plug in these values for this matrix, we're going to have minus 1/2, 1, 0, 1/2, 3/2, 2, 1, 1, 1. So to get our vector of limiting probabilities, we're going to invert this guy, multiply it times the transpose of that guy, and that should spit out our limiting probabilities. So give that a shot in MATLAB and check on the Blackboard page for an example. And I'll have a little bit more in an email and on Blackboard about that. So definitely do a practice problem, and we'll go from there.